Right, good. So you get the idea that basically the hypotenuse is always the same, it's always the longest side or the side opposite the right angle, and then the adjacent and the opposite sides will change depending on which angle you're focusing on. So in this triangle, this was the adjacent side, whereas in this triangle, this was the adjacent side. So it's always given in terms of what angle you're looking at. Okay, so I really want to build on this idea. We've noticed, and we've kind of tried to explore a little bit, that the side lengths are given in terms of the angle. So the bigger the angle, the bigger the side length. Okay? Now, obviously, because I can enlarge this triangle and make it smaller and bigger, then actually the side lengths will change by default. But what will always remain the same in a right angle triangle is a comparison between these two sides. So, for example, if I have a triangle where this angle down here is maybe 30 degrees, okay, then it just so happens that if I take this side and compare the sizes to each other, they'll always be the same comparison. Okay? Now we give that a special name when we're comparing two numbers to each other. Do you know what it's called? Do you know what we call it in maths if we compare two numbers to each other?
Comparing.
It is comparing, but we give it a name, we call it ratio. So a ratio is literally just a comparison of size, okay? For example, if I take 4 and let's say 8, okay? If I wanted to compare 4 to 8, then I would say the ratio of these two things, so I write with 2 dots down the middle, will just be a half. Because that basically means that 4 is half of 8. Does that make sense? Okay? So a ratio is literally just a comparison of size. So this you'll undo here. Okay? I'm just taking two sides and I'm comparing the lengths of each other. So I'm making a comparison, therefore I write it as a ratio. So I can write it with 2 dots down there, or I can write it as a fraction. It's the same thing. Okay. So what I'm trying to do here is really say, well, okay, you give me an angle. Okay, so you give me an angle in your right angle triangle. You actually tell me the size of your angle. You should then be able to tell me, or I should then be able to tell you, if I was going to compare two sides together, so for example, the opposite and the adjacent, okay, and if you told me that that was, I don't know, 30 degrees or something, okay, I should be able to tell you how many times the opposite side is relative to the adjacent side. So is it twice as big, 3 times as big, maybe 2 times smaller? So I should be able to tell you a comparison of size, given that I know what angle what your angle size is. Okay, that's basically the fundamental idea, and it's kind of the feature which people noticed a long, long time ago, the ancient Greeks. Okay. Now, because there are 3 sides, how many ratios, how many comparisons can I make?
3.
Exactly. Yeah, 3 sides. I can compare that one, that one, that one, and that one, or that one and that one. Okay. So because I can make 3 comparisons, I give them a special name. So what comparisons can I make first of all? Well, I can compare the opposite and the hypotenuse, okay? So I'm going to write it as OPP for short, for opposite, and HYP for hypotenuse, rather than writing the whole word out. What else can I compare? What are the 2 sides?
Opposite and adjacent.
Opposite and adjacent, fantastic. What else can I compare? What's the other one that's left?
Adjacent
The hypotenuse, isn't it? We haven't done that pairing. Okay, so the other one is the adjacent and the hypotenuse. Okay, so these are the 3 comparisons that I can make. I can compare the opposite side to the hypotenuse side, and find the relationship between those 2 sizes, adjacent and hypotenuse, and the opposite and adjacent. Now, because these are really important, like clearly they're really important, you're comparing the 2 sides, so all 3 sides in relation to each other, because they're really important, we give these ratios a special name, okay? And they're Greek names, okay, so they're Greek names, they're named after whoever came up with them in Greek. So if we're comparing the opposite and the hypotenuse, we call that the sine ratio, which we write as S-I-N for short, okay? If we're comparing the adjacent and the hypotenuse, do you know what we call that?
Cosine.
Yeah, the cosine, or COS for short, cos for short. What about if we're comparing opposite and adjacent?
Tan.
Good, the tangent, or the tan ratio, okay? Now, are you happy that these 3 ratios, you need to give me an angle? In order for these ratios to work, like there's no good unless you actually tell me what the size of your angle is. Okay, so I need to know the size of the angle then I will be able to tell you how many times bigger the opposite side is in relation to the hypotenuse, as an example. So I always need to do this in terms of an angle. So I could write alpha, I could write beta, it doesn't really matter. I'm going to write alpha because I want to compare that angle, but if I wanted to compare beta, I'd obviously give beta there instead. Okay, so it's always cos of an angle, sine of an angle, or tan of an angle. Okay, so you always need to give me an angle. It's no just writing sine equals opposite of hypotenuse. You always need to write a sine of an angle. Okay. So have you seen this before? Okay, fantastic. So one way that I could write this, if I take these three kind of things, would you be happy that this could be written as S equals O over H? That's one way that I could abbreviate this to remember it. Okay. So rather than having to write these out every single time, I could write S for sine equals O over H. If I wanted to convert that to a triangle, I could write that as S O H. So are you familiar with using formula triangles? Yeah, so you basically cover up the thing that you want, and that will tell you how to relate the two remaining things together. And then obviously for cos, it's going to be C, A, and H. And the last one is T, O, and A. So my triangle's got a little bit flatter there, but that's fine. There's H. Okay, so one way that people like to abbreviate this is SOH, SO, CAH, that's Ka, and TOA, that's TOA. So one way that people like to abbreviate is that SO, Ka, TOA. So it's a way of remembering it, okay? And what this literally relates to are these formula triangles here. Okay, so what I'm going to do now is just show you a question, and we'll talk through it. We'll talk through how to answer this question. So let me give you a right angle triangle. Let me give you something like this. That's right angled. Let's suppose this angle down here is going to be 30 degrees. Okay? Let's suppose that this side is worth 4 centimeters or 4 units. Okay? And let's suppose I wanted to find this hypotenuse. I wanted to find this longest side. So this is how you go about answering this question. At least this is how I answer this question. Have you seen this before, by the way? Yes, you've done all this before. Okay, we'll go through this really quickly then. So if that's the angle which I'm interested in, what would I label that side as? Opposite, adjacent, hypotenuse? Good. So I'm just going to write OPP for short. What do I label that side as?
The H.
Yeah, the hypotenuse or the H, that's fine. Okay. So therefore, I look up here. So remember, I have 3 formula triangles, which I can use. I have 3 formula triangles which I can use, okay? I'm only interested in the opposite and the hypotenuse side, which means anything else I'm not interested in. I'm not interested in the adjacent. So if I go through here and find anything with an adjacent in, I can rule that triangle out. So that triangle is gone, that triangle is gone, that means I'm going to be using S, O, and H. So remember, I'm after the hypotenuse, so I'll cover that thing up. So I can say H will be equal to O divided by S. And then I just fill in what I know. So H is what I'm after, that's X. O is equal to 4. And the S, remember, is short for sine. So it's going to be sine of 30 degrees. Okay? And because I know that sine of 30 degrees is equal to 1/2, that basically means that if I compare the opposite and the hypotenuse, that means that the hypotenuse should be twice as big as the opposite, or the opposite should be half as big as the hypotenuse. Okay? So just remember, the reason why sine of 30, if you stick sine of 30 in your calculator, that comes out as a half. What that literally means is that because I'm comparing the opposite and the hypotenuse, it means the opposite is half as big as the hypotenuse. So in that case, the hypotenuse should be 8. You happy? But if you stick that in your calculator, you will always get x equals 8 anyway. Does that make sense? You've seen this before, right? Okay. I will just do one more example just to show you what happens if you need to find the angle. So if I give you some weird and funky kind of looking right angle triangle like that, that's not right angled at all. There we go. So that's my right angle up there. Let's suppose this is the angle which I'm after, so this is my theta, this is the angle which I don't know. Let's suppose this is 5 and this is 7, okay? Then what I can do here is just label up my triangle, same as before. So okay, I'm looking for, this is my opposite, this is my adjacent. So therefore I look at my SOHCAHTOA, so SOHCAHTOA. I look for what I'm not interested in this case the hypotenuse, rule anything with a h in, out, so that's out, that's h, that's out. So I'm after TOA. So I'm after the angle in this case, well the angle is related to the t, so therefore I can say that t is equal to O divided by A. So tan of theta will be equal to O, which in this case is 5, over the adjacent, which in this case is 7. Now how am I going to find theta here?
Why is it 10?
Why is it tan? Really good question. Have a look. I'm after this. I've labelled this side as the opposite. This side is the adjacent. So I go through my ratio, SOHCAHTOA, and I rule anything with a h in. I rule that out. Because I'm not interested in the hypotenuse at all. Yeah? So sine has got a h in, not interested in that. Cosine has got a h in, not interested in that. Therefore, that's the triangle I'm interested in. Is that okay? So you should have tan of theta is equal to, well in this case, 5/7. Yeah? So how am I going to find theta here? How am I going to find my angle? How did you find that?
Shift.
Good, excellent. So it's the tan inverse. Okay, there's a button on your calculator just above the tan, which you find by doing shift tan, and that's absolutely right. So what did you get to 1 decimal place as your angle?
35.5.
35.5, thank you. So 35.5 degrees. Okay, 35.5 degrees. And that's my angle down there. So does that make sense? It's relatively straightforward, okay? As long as you have SOHCAHTOA in your head, then you just basically say, okay, label up my sides. You always label it up in terms of the angle which you're looking at, okay? So whether it be that angle or that angle, you always label those sides up. Then you go through and you say, what am I not interested in? So in this case, with this triangle, you weren't at all interested in the adjacent. You hadn't been given the adjacent, and you weren't interested in finding the adjacent. So anything with an A in, you rule out. So that's out, that's out. That means the thing which is left is the thing which you want. So in that case, SOH. Okay? Then you just literally say, well, okay, I'm interested in the hypotenuse. Cover that up. So h must be equal to O divided by s, which is what I write down. And I just fill in what I've got. So h in this case is x, O is 4, and s, well, that's short for sine of my angle, which is 30. Stick that in your calculator, and you'll get the answer out. Make sense? You've done loads of questions on this before, presumably? Okay, fine.